Good morning, everyone. Today we will discuss atmospheric refraction, means refraction through atmosphere. Have you ever seen objects through hot air rising above a fire or a radiator? They appear to be moving randomly or flickering. This is because the hot air is turbulent and causes the light to bend and scatter in different directions. Means light is coming from rarer to denser medium, means light have to travel to different mediums, that's why bands, and means they appear to be moving randomly or flickering. The hotter air is lighter, means less dense than the cooler air above it, and has a refractive index slightly less than that of the cooler air. Since the physical conditions of the refracting medium are not stationary, the apparent position of the object as seen through the hot air fluctuates. This wavering is thus an effect of atmospheric refraction, means refraction of light by the Earth's atmosphere on a small scale in a local environment. In Earth's atmosphere, there are different layers, and different layers have different densities. As we go higher, the density will decrease. Light is coming from space. When it enters the atmosphere, light have to cross different layers to reach the surface of the earth, but different layers have different densities, means they have different refractive index. Upper layer is rarer, act as rarer medium, and lower layer in atmosphere act as denser medium. Due to different densities and different refractive index, light bends continuously, and this refractive index or densities of different layers are not fixed. The twinkling of star is a similar phenomenon. Let us see how we can explain it. The twinkling of a star is due to atmospheric refraction of starlight. Star acts as a point source of light. The starlight, on entering the Earth's atmosphere, undergoes refraction continuously before it reaches the Earth. The atmospheric refraction occurs in a medium of gradually changing refractive index, means different layers have different refractive index and they are continuously changing due to different physical condition of atmosphere. Since the atmosphere bends starlight towards the normal, the apparent position of the star is slightly different from its actual position. The star appears slightly higher than its actual position when viewed near the horizon. Further, this apparent position of the star is not stationary but keeps on changing slightly. Since the physical conditions of the Earth's atmosphere are not stationary, since the stars are very distant, they approximate point-sized source of light. As the path of rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of starlight entering the eye flickers. The star sometimes appears brighter and at some other time fainter, which is the twinkling effect. Why do not the planets twinkle? The planets are much closer to the Earth and are thus seen as extended sources. If we consider a planet as a collection of a large number of point sized sources of light, the total variation in the amount of light entering a eye from all the individual point sized sources will average out to zero, thereby nullifying the twinkling effect. Advanced sunrise and delayed sunset. The sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. By actual sunrise, we mean the actual crossing of the horizon by the sun. The time difference between actual sunset and the apparent sunset is about 2 minutes. The apparent flattening of the sun's disk at sunrise and sunset is also due to the same phenomenon, means due to atmospheric refraction. The interplay of light with objects around us gives rise to several phenomena in nature. The blue color of the sky, color of water in deep sea, the reddening of the sun at sunrise and the sunset are some of the wonderful phenomena we are familiar with. In the previous class, you have learned about the scattering of light by colloidal particles. The path of a beam of light passing through a true solution is not visible. However, its path becomes visible through a colloidal solution, where the size of the particles is relatively larger. The Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust, and molecules of air. When a beam of light strikes such fine particles, the path of the beam becomes visible. The light reaches us after being reflected diffusely by these particles. The phenomenon of scattering of light by the colloidal particle give rise to Tyndall effect. This phenomena is seen when a fine beam of sunlight enters a smoke-filled room through a small hole or window. Thus, scattering of light makes the particle visible. Tyndall effect can also be observed when sunlight passes through a dense forest. Here, tiny water droplets in the mist scatter light. The color of the scatter light depends on the size of the scattering particles. Very fine particles scatter mainly blue light, while particles of larger size scatter light of longer wavelengths like red color. If the size of the scattering particle is large enough, then the scattered light may even appear white. Why is the color of the clear sky blue? The molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of visible light. These are more effective in scattering light of shorter wavelengths at the blue end than light of longer wavelength at the red end. The red light has a wavelength about 1.8 times greater than blue light. Thus, when sunlight passes through the atmosphere, the fine particles in air scatter the blue color, means shorter wavelengths, more strongly than red. The scattered blue light enters our eyes. If the earth had no atmosphere, there would not have been any scattering. Then the sky would have looked dark. The sky appears dark to passengers flying at very high altitudes, as scattering is not prominent at such heights. You might have observed that danger signal lights are red in color. Do you know why? The red is least scattered by fog or smoke. Therefore, it can be seen in the same color at a distance. Today we have learned atmospheric refraction, means refraction through different layers of atmosphere, apparent position of star and twinkling of star, then advanced sunrise and delayed sunset, and this is also due to atmospheric refraction. Now light also scatter with minute particles present in atmosphere, means scattering of light, Tyndall effect, and we also studied about why the color of the clear sky is blue. This is all about today's topic. Thank you and have a nice day.